Hi, we can use trigonometric ratios to find any unknown side of a right angle triangle. And to do this, we use the given information to determine the best ratio. And then we make the unknown side the subject of the ratio so we can solve. Let's start by writing down our ratios. Sine theta is equal to opposite over hypotenuse. Cos theta is equal to adjacent over hypotenuse, and tan theta is equal to opposite over adjacent. Now we can look at an example. Calculate x correct to one decimal place. The first thing we need to do is find the hypotenuse. So let's draw a line from the 90-degree angle to the opposite side of the triangle. This is our hypotenuse, which is 12 units long. So we can make a note of this up here, and we can say h is equal to 12. Next, we need to look at our given angle of 43 degrees, and we can draw a line from 43 to the opposite side of the triangle. Here is the x value we need to find, so we can make a note of this as well, and we say the opposite side is equal to x. Now we have an angle, the length of the hypotenuse, and we need to find the length of the opposite side. So we need to find a trigonometric ratio that contains both the opposite and the hypotenuse. Sine uses both of these, so we can use this to solve for x. So now we can say sine, instead of theta, we're going to say 43 degrees, is equal to the opposite, which is x, over the hypotenuse, which is 12. Now we need to get x by itself, and to do this, we need to multiply both sides by 12. So on the left, we're now going to have 12 multiplied by sine 43 degrees, and this is now equal to x. And now we can take out our calculators, and we can say 12 multiplied by sine 43 degrees is equal to 8,183. Let's round off to one decimal place, and we get an answer of 8,2. Let's do another one. Let's start by drawing a line from the 90-degree angle to the hypotenuse. The hypotenuse has a length of 16 units. So let's make a note of this, and we can say h is equal to 16. Now we can look at our angle. There is no value for the opposite side of the triangle, so let's find the adjacent side. We have just found that this is our hypotenuse, so the adjacent side must be the other side of the angle. The adjacent side has a length of x, so now we can say adjacent is equal to x, and now we can solve. Now we have an angle, the length of the hypotenuse, and we need to find the length of the adjacent side. So we need to use the ratio that contains both the adjacent and the hypotenuse. Cos uses both of these, and we can use this to solve for x. So we can say cos, instead of theta, we're going to use our angle, 32 degrees, is equal to the adjacent side, x, over the hypotenuse of 16. And now we need to get x by itself, so we need to multiply both sides by 16. And we get 16 multiplied by cos 32 degrees is equal to x. Now we can take our calculator, and we say 16 multiplied by cos 32 degrees is equal to 13,568. Let's round off to one decimal place, and we see that x is equal to 13,6. Let's do one more. Again, let's draw a line from our 90-degree angle to the hypotenuse. In this case, we do not have a length for the hypotenuse, nor is it a side we need to find. So let's make a note of this, and over here we can write h for hypotenuse. Now let's look at our angle. Let's draw a line from our angle to the opposite side of the triangle. This is our opposite side. It is the length we need to find. So let's make a note, and up here we can say the opposite side is equal to x. Now we can look at the adjacent side. we know that this is our hypotenuse, so this must be our adjacent side. It has a length of 14,6 units, so we can make a note up here, and we say A is equal to 14,6. Now we have an angle, the adjacent side, and we need to find the length of the opposite side. So we need a ratio that uses both the opposite and adjacent sides. And tan is the only ratio that uses both of these. So now we can say tan, instead of theta, let's use our angle of 23,4 degrees, is equal to our opposite side, which is x, over our adjacent side of 14,6 units. Again, to get x by itself, let's multiply both sides by 14,6, and we get 14,6 multiplied by tan 23,4 degrees is equal to x. Now we can take out our calculator, and we say 14,6 multiplied by tan 23,4 degrees, close the bracket, is equal to 6,317, round off to one decimal place, and we get an answer of 6,3. Now, there may be cases where you will need to reorganize the equation just a little bit, and let's look at some examples. Again, let's start by finding our hypotenuse, and we can draw a line from the 90-degree angle to the opposite side. This is our hypotenuse, but it's also the side we need to find. So we can make a note up here, and we say h is equal to x. Next, we can look at our angle of 17 degrees, and we can draw a line to the opposite side of the triangle. Our opposite side has a length of 12 units. So let's make a note of this up here as well. Now we have an angle, the length of the opposite side, and we need to find the value of the hypotenuse. So we need a ratio that uses both the opposite and the hypotenuse. Sine uses both the opposite and the hypotenuse. So now we can say sine, instead of theta, let's use our angle of 17 degrees, is equal to the length of the opposite side, 12, over the hypotenuse, which is x. Now our next step is to get x out of the denominator of the fraction. And to do this, we multiply both sides by x. So now we'll have x multiplied by sine 17 degrees is equal to 12. But to solve for x, we need x by itself. And in this case, we now need to divide by sine 17 degrees. So on the left, we're left with x is equal to 12 over sine 17 degrees. And now we can take out our calculator, and we say 12 divided by sine 17 degrees, close the bracket, is equal to 41,043, round off to one decimal place, and we see that x is equal to 41. Let's look at another one. Again, let's start by drawing a line from our 90-degree angle to the opposite side of the triangle. This is our hypotenuse. Again, it's also the side we need to find. So we can make a note of this up here, and we say h is equal to x. Now we can find another side. Let's look at our angle of 22 degrees. There is no value for the opposite side, so let's find the adjacent side. We have just found that this is our hypotenuse, which means that this must be our adjacent side because it is next to our angle. Let's make a note of this as well, and we say A is equal to 31 units. Now we have an angle, the adjacent side, and we need to find the length of the hypotenuse. So we need to use a ratio that uses the hypotenuse and the adjacent side, and cos uses both of these. So now we can say cos, instead of theta, let's use our angle of 22 degrees, is equal to the adjacent side, which is 31 units, over our hypotenuse, which is x. Let's move x from the denominator of the fraction, and we're going to multiply x by both sides. So we can say x multiplied by cos 22 degrees is equal to 31. Now to get x by itself, we divide both sides by cos 22 and we get x is equal to 31 over cos 22 degrees. And now we can use our calculator. So we say 31 divided by cos 22 degrees, close the bracket, is equal to 33,434, round off to one decimal place, and we see that x is equal to 33,4. Let's do one more example. Let's draw a line to find our hypotenuse. Now in this case, we aren't given a value for the hypotenuse, nor is it the side we need to find. So let's mark it as h, so we know where our hypotenuse lies. Next, let's look at our angle, and we can draw a line from the angle to the opposite side of the triangle. Our opposite side is a length of 7 units. So let's make a note up here, and we say the opposite side is equal to 7. Now we know that this is our hypotenuse, which means that this is our adjacent side. It is the side we need to find. So up here, we can say A is equal to x. Now we have an angle, the opposite side, and we need to find our adjacent side. So we need a ratio that uses both the opposite and adjacent sides, and tan uses both of these. So now we can say tan, instead of theta, let's use our angle of 43 degrees, is equal to opposite, which is 7, over adjacent, which in this case is x. Now we can multiply x by both sides, and on the left we get x multiplied by tan 43 degrees is equal to 7. Now let's get x by itself, which means we have to divide both sides by tan 43 degrees. On the left we have x is equal to 7 over tan 43 degrees. Now we can take our calculator and we say 7 divided by tan 43 degrees, close our bracket, is equal to 7,506, round off to one decimal place, and we see that x is equal to 7,5.